everyone, welcome back. This video is the second video in my series of walkthroughs of the TryHackMe Attacking and Defending AWS learning path. You don't have to watch the videos in any particular order. This is the second room in the learning path. Let's go. All right, so here is the AWS Basic Concepts room. Learn basic concepts relevant to AWS. The room has a few learning objectives. We're going to learn about basic technologies associated with the AWS platform. These technologies represent foundational concepts for how you interact with AWS and AWS services. We're going to learn about the basic security boundary, an AWS account, and the root user account that's associated with each AWS account, the IAM, Identity and Access Management infrastructure inherent to using AWS, what is an AWS region and why that matters when you interact with services. So we learned a little bit about regions in the first room. I guess we're going to touch back on that and learn more. How AWS organizations can streamline operations through central management of many AWS accounts. I use organizations to manage all my AWS accounts, so I do like this topic. What is a virtual private cloud, VPC, and why you will almost inevitably need one or many when using AWS. In my experience, I somehow always end up needing many. This information will help you become familiar with core AWS services and features. Using this information, you'll be better prepared to understand and troubleshoot new challenges as they arise in your cloud journey. All right, so in here we just click completed to say we are ready to start the room, and let's go. Now that we made it through that introduction task, we're getting into the actual basic concepts, which is the point of the room. So for task 2, the first basic concept is AWS account and root user. Let's see what this is all about. AWS account is a container for your AWS resources. AWS accounts are designated by a 12-digit number known as an account ID. Each AWS account ID is unique and can never be reused, so that's important to remember. Account IDs are unique identifiers. An account is a security boundary in association with AWS Identity and Access Management. Learning AWS IAM is an entire module by itself. Literally, there's a module about it in the learning path. But it is key to understand that AWS IAM or root user credentials are the only way to access the AWS control plane. Even when using single sign-on and third-party identity providers, the permissions are granted to an AWS IAM user or role. So even if you're accessing an AWS account using some sort of federated identity, like you've signed in through Active Directory or something like that, on the back end, you're assuming a role or you're assuming some sort of IAM principle within AWS. And I bet we're going to learn more about that later. Point is, you're not doing anything in AWS without IAM, Identity and Access Management, being involved somehow. And that brings us to, looks like the AWS account root user. To sign up for an AWS account, AWS users provide a root user email address. An email address can only be used as the root user email address for one AWS account. So your email cannot be the root email for more than one AWS account. Although there's something called email plus addressing that you can use to get around this a little bit. So if you haven't heard of that, you can Google email plus addressing or something like that. But that's what I personally use to be able to create multiple AWS accounts that use the same email. And the root user is considered an IAM super user and has complete administrative permissions against the AWS account. Generally, AWS customers are recommended not to use the AWS account root user credentials unless performing a task that only the root user can perform. You really want to avoid having your root user account be your day-to-day activity account. You want to be logging in as the root user as rarely as possible. By default, root users do not have multi-factor authentication enforced. Furthermore, root accounts that do not have MFA enabled or a phone number set are susceptible to a weak password reset workflow attack. This is commonly the case for AWS accounts created automatically using the AWS Organizations service, which we're going to discuss more later. Yes, so obviously having MFA set up on your AWS account is essential. Also, think about it. It's essential that whatever email account you are using as your root email for your AWS account, whatever email you've used to set up the AWS account, you need to make sure that email account itself has all those best practice security things set up, like multi-factor authentication. Because if a bad actor were to compromise that email account, that is the root email for the AWS account, they're one step closer to compromising the AWS environment. So MFA everywhere, strong passwords everywhere. That's really important. And oh, okay. Sorry, jump the gun. If an attacker gains control of the email inbox for an AWS root user without MFA or a phone number on the account, the attacker will be able to send a password reset email and complete a takeover of the targeted AWS account. So having MFA and the phone number on the AWS account is a great protective measure. And then make sure your email is secure as possible as well. If you have access to an email inbox or are looking to target email addresses as potential root users, you can use tools like Quiet Riot to enumerate valid root user email addresses. And they have a link to Quiet Riot here. And Quiet Riot is an enumeration tool that you can use, I believe, in all three cloud providers. Let me double check that. But you can use it to enumerate cloud principals without you yourself being authenticated. Let's see. So, yeah, unauthenticated enumeration of AWS, Azure, and GCP principals. So, the big three cloud providers. I wonder, hopefully, we'll get to use this tool later in the learning path, which should be very fun. Anyway, here are our questions for task 2. How many digits are in an AWS account ID? So, that is 12 digits. And remember, those are unique account ID identifiers. Does AWS require customers to enforce MFA by default for root user credentials? At the time this was written, I'm sure the answer was nay. So that's what I'm going to put. But there have been a lot of changes around this rolling out recently. So I'm making this in early 2024, this recording. And AWS has started to require MFA in different circumstances. I'm not sure off the top of my head, but I'll link below to some of the announcements and stuff. But AWS is starting to actually enforce requirements on every account related to MFA, which is a good move forward because everyone should have that set up. It's a no brainer. So we'll hit submit on nay. Whoop, whoop. Our answer is correct. And we will move on to task 3. For task 3, our next basic concept is identity and access management, or IAM in AWS. And this is fundamental to all things AWS, really. As identity and access management, or IAM specifically, means the capabilities and features of the IAM engine in service of AWS. This is the underlying system built by AWS to determine how IAM principals are granted access to specific services, resources, and capabilities in AWS. Essentially, IAM principals are the identities that AWS recognizes as having privileges in relation to AWS resources in the AWS IAM engine. Boy, I just said AWS a lot of times. And I'm someone who talks about AWS all the time anyway. But that was a lot, even for me. If you didn't understand much of that yet, that's okay because this is really just like a basic introduction, and then we're going to learn a lot. And then we're going to learn about each of these concepts in more detail based on what I saw in the learning path. You can typically think of IAM principles as like the who, even though IAM principles aren't necessarily always one to one with a human user, but you can think of principles as the who is allowed to do something, who is getting permission to do something. And then you can use the following policy evaluation logic from AWS to determine whether and what type of access an AWS IAM principle has to a specific AWS service and resource. The policy evaluation logic image starts with the implicit deny. So I've seen this image many times, and there's a great YouTube video where one of the IAM SMEs from AWS walks through this policy evaluation logic and does a much better job of it than I would ever be able to do. So I'll maybe link that in the video description. It's a great supplement to this image here in TryHackMe. I'll make a quick attempt to walk through the diagram, but you should really watch that YouTube video because she does a masterful job. Here's the idea. Whenever a request is made in AWS, we go through this policy evaluation logic. And as we walk through the policy evaluation logic chart, I want to give an example. If you're at all familiar with AWS, you're probably familiar with S3 buckets, AWS S3 buckets, which is object storage in the cloud. When you use S3, you have different buckets that have different objects in them. And let's pretend we have an S3 bucket and it has one object in it, and we have a user who is trying to download that object from the S3 bucket. So let's pretend that that is the request. It's a get object request to S3. So whenever that request happens for something to happen in AWS, we go through this policy evaluation logic. So the user has made a request to download the object from our S3 bucket. And the decision starts with deny. IAM operates on what's called implicit deny. What implicit deny means is that whenever a request is made in AWS, the default decision is to deny that request. So unless there's some reason in later on in this flowchart to approve this request to download the S3 object, we're going to deny it. But before we deny the request, we're going to go through this logic and double check if maybe we should allow it instead. So we're going to evaluate all the applicable policies. First of all, is there an explicit deny? If there is an explicit deny anywhere in any of these different policies downstream, it's an automatic deny. A deny in any policy overrides any other allow that might exist. Then we're going to check if the principal's account is a member of an organization with an applicable SCP, which stands for Service Control Policy. So remember, The principal is the who that's making the request, the entity that's making the request. In our example here, the principal is the user that's trying to download the S3 object. So we're going to check, is that account that the user is coming from a member of an organization with a service control policy? And does that service control policy have an allow in it? If there's no allow in the service control policy, it's a deny. If there is an allow in the service control policy, we can move on and keep evaluating. Does the requested resource have a resource based policy? This is the reason I chose S3 as in our example. So, some AWS services have resource based policies and some do not. S3 is an AWS service that does have a resource based policy, and buckets have a policy attached to them that can have different rules in it. So, we check if the S3 bucket has a resource based policy attached to it. It might not. If there is a resource based policy attached to it, we check if there's an allow in that resource based policy, and then some more complicated stuff happens that's kind of out of scope for this. But if there is no resource based policy, or if there's no allow in the resource based policy, and remember, if there's no deny in the resource based policy, then we check if the principal has an identity based policy. And this is the kind of the most basic building block you hear about with IAM. We're going to check the policies attached to the user. And if the user is a member of a group, we would also check the policies attached to that user group, and we're going to see, is there anything in the policies attached to the user that allows them to access this bucket and download the object. We're going to check if the user has an identity based policy attached to them, or if they're maybe in a group that has policies attached. If they don't have any policies attached to them, the user doesn't have permission to do anything, the implicit deny kicks in, because the default, if you don't have an allow for anything, is denied. So you're denied. However, if they do have an identity based policy attached to them, then we evaluate that policy. We check if there's an allow in the identity based policy. If there's not, they're denied. If there is, we move on to check if the principal has a permissions boundary. I'm not going to get into detail about what a permissions boundary is here. I imagine we might learn about it later, but just know that's another thing we have to check. And then, is the principal a session principal? So this is another thing I'm not going to dive all the way into right now, but just know that's another check you do if we're looking at a session principal or not. If they're not a session principal, we'll do an allow. This is pretty complicated if you're brand new to AWS IAM. A few of the most important things to take away here: the decision starts with a deny. It's an implicit deny always in IAM. You need to have an allow to be able to do something. And remember that an explicit deny, so that means a deny written into any of these policies, overrules and allow anywhere else. Requests are denied by default, and an explicit deny trumps all. If you can remember those two things, that's a pretty good start. And you can always come back and refer to this diagram as you're learning this more. Maybe we'll be able to refer back to it in some of the future rooms in this learning path. Anyway, let's close out of that and see what else is going on. IAM roles. Okay, this is a great topic. AWS IAM roles are AWS principals that have permissions in relation to AWS services and resources. These IAM roles are notable because of a feature known as assume role or switch role. These terms mean that other identities recognized by AWS IAM are allowed to gain the privilege of a particular IAM role. Which identities are allowed to assume or switch to a role is determined by what is known as the assume role trust policy that is attached to each IAM role. So a role is designed to be used temporarily. You can think of it as kind of being like checked out, taken off the shelf, used to do something for a limited amount of time and then put back. They're assumed by human users, and they're often assumed programmatically by your software that's running in the cloud. And the assume role trust policy determines who's allowed to check that role out, take it off the shelf, and use it to do something. This is what the assume role trust policy looks like. I would have to assume that we're going to see a lot of these trust policies to come as we learn more about IAM. So we can see in this above example, the role maintenance role is in this AWS account with the unique ID of all these ones. And this maintenance role would be allowed to assume whatever other role this trust policy is attached to. Perhaps the maintenance role needs to go into another account and do something. The other account has a role in there that the maintenance role is allowed to assume, for example. Numerous types of AWS principals can be specified in an assume role policy, including federated identities. And federated identities means you're using an identity from somewhere else to have permissions in another domain. Like a really common example would be you log in somewhere with your Microsoft Active Directory, and then you're able to use that identity you have through Active Directory to authenticate somewhere else and have permissions in some other domain. And maybe that's what we're about to get into more here. federated identities and identity providers. AWS IAM supports the use of Security Assertion Markup Language, which is SAML, and OpenID Connect, OIDC, to federate identities from third party identity providers such as Azure Active Directory, Ping Identity, Okta, Facebook, and other SAML or OIDC providers. This means that identities registered with these third party providers can be provisioned access to AWS IAM roles with privileges inside of AWS accounts. In 2017, AWS furthered this integration with Organizations and IAM Identity Center, which used to be called AWS SSO or single sign on. Looks like we have a section about IAM Identity Center here. I'm a huge fan of Identity Center. I use it to manage access to all my AWS accounts, and it's good for security. It's also just a lot more convenient if you have more than one AWS account. I think it's a great product. If you want to ever set it up, I do have 2 videos on my channel about how I set it up, but first let's learn what it is. This Identity Center allows organizations to provision access across AWS accounts and applications hosted as part of an organization. Inside an AWS organization, AWS Identity Center will allow customers to provision third party identity provider access to specific permission sets in a single AWS account, an organizational unit, which remember might include multiple AWS accounts, or organization root, the root account at the top of the tree. Furthermore, I don't know, that word cracks me up. Furthermore, using capabilities such as System for Cross Domain Identity Management, customers can automatically update which permission sets a user has based on user attributes or group membership in the originating identity provider. This means that organizations can seamlessly manage access to AWS from the source identity provider without the manual overhead associated with IAM provisioning. All right, that was a lot. If you just got a whiff of the concepts, you're just starting to learn about it, that's totally fine. So let's see what this diagram is all about. AWS single sign on use cases. And remember, as was just mentioned, single sign on is what Identity Center used to be called. So this is probably a diagram from the AWS docs before that name change occurred. This is talking about Identity Center, is what it's currently called now. So you can see here the example is an on premise Microsoft Active Directory where some sort of enterprise has on premise users and groups that they're already using Microsoft Active Directory to manage in their data center. And they're using something called the Active Directory connector to then use those users and groups in their AWS Identity Center setup as well. And they're going to use those users and groups to manage permissions to the different AWS accounts in their AWS organization. So, permission management is one piece of it. And then they're also going to use Identity Center or AWS SSO at the time to take all those users and groups and use them to manage single sign on access to the AWS accounts. So that's how users can federate into the AWS accounts and do things, is using the Active Directory identities. They're going to use it to manage single sign on access to different cloud applications they're using. So Dropbox, Slack, Office 365 are the examples given. And then they can also use it to set up single sign on access to custom applications they use that use SAML. So as long as the application uses SAML, they can use Identity Center to manage SSO, all based on these identities that the enterprise is already using in their on premise Microsoft Active Directory. And again, I think we're going to see more of this later. So don't worry if it's a little complex just for starting out. And look, this note says the same thing. This task is only meant to explain the basics of AWS IAM. Please see the room dedicated to IAM for an in depth look at these technologies. So we'll learn more as the path continues. Now, let's see. Here are our questions for task 3. What logic can be used to determine the access of an AWS IAM principal? So that would be policy evaluation logic based on what I'm seeing for these little asterisks. I think it'll just be policy evaluation, if I can spell it. Whoop, whoop. So policy evaluation logic is used to determine the access of an AWS IAM principal. And then what policy determines if an IAM principal has the ability to gain the privileges of a particular IAM role? So that's the assume role trust policy we saw earlier up here. Assume role trust policy. Let's see which parts of that they are wanting for the answer. So we'll scroll down back here and we're looking for, oh God, I can't even tell what that is. So let's just say, let's try assume role because it looked like it was no spaces. Okay, awesome. So the assume role trust policy, or you'll sometimes just hear it called the trust policy, determines if an IAM principal uh, is able to assume and then use a particular IAM role. That is task 3. Well done. So that's task 3 completed. And I was going to just continue on to task 4, but TryHackMe just let me know that my streak got extended for another day. And that made me look up at the clock and realize that it's just turned midnight and I'm really old, so I can't stay up late like that anymore. So I am going to pause this for now and pick it back up tomorrow. So I will see you soon for task 4. Okay, I'm back. It's not midnight anymore. It's daytime now, so that's good. And I'm going to keep working through this AWS Basic Concepts room. Task 4 is Basic Concept AWS Region. This starts with global versus regional service. AWS services are considered either global or regional. A global service means that the service supports a central control plane and data plane, which TryHackMe describes here as management APIs in parentheses, that does not resolve to a specific AWS region. If you're not familiar with these terms, control plane and data plane, these are networking terms. And one way I've always heard this described is that control planes make the decisions and data planes actually move traffic and data around based on the decisions made by the control plane. Or like the metaphor, I guess, that I've always heard is you could think of the control plane as like the brain, and then the data plane is like the arms carrying out the commands that the brain makes as data is moved around. Also, here in TryHackMe, there's links to looks like Wikipedia about these terms. So here's the Wikipedia for control plane, and I assume the Wikipedia for data plane. So you could come in here and read more to get up to speed if needed. The way I think about control plane versus data plane within the context of AWS services typically is control plane events are going to be more like management administrative events versus data plane events are more day-to-day operations, how data is handled. S3 service is a really good example of this. Control plane events within S3 would be things like creating an S3 bucket, deleting an S3 bucket, making a request to get a list of all the S3 buckets you have. Whereas data plane would actually be like putting an object into your S3 bucket or reading an object from your S3 bucket, or those day-to-day data events. The point here being that global services have one central control plane and data plane. And when you make requests, those resolve to that central control plane and data plane. Whereas with a regional service, the requests that you make, the events, they're going to resolve to a control plane and a data plane in that region to those regional data centers. The example they give here, for instance, US East 1 resolves to Northern Virginia data centers in the United States, and they have their own US East 1 control plane and data plane. This is a valuable concept for organizations with data sovereignty requirements, but it also serves as redundancy capability for organizations to architect multi-region workloads. We can find a list of all the regional AWS services linked here, and we could open that, but really almost every AWS service is going to be a regional service. So it's probably easier to look at the notable global services that have the global control plane and associated data plane. These are the big ones to keep in mind. CloudFront, which is content delivery. So CloudFront allows AWS customers to expose resources to the public internet. Route 53, which is the domain registrar and does DNS. Organizations, AWS Organizations is a global service. And then IAM, Identity and Access Management. IAM determines what services and resources identities can access. And we're going to learn much more about that coming up, I'm sure. Then this part gets kind of juicy because they start talking about security token service, STS. And it says here, STS is a key service to understanding AWS security as it allows AWS and third-party identities to retrieve temporary access credentials. Uniquely, STS is both a global and regional service, meaning that there are both global API endpoints you can make requests to and regional API endpoints. And then this is the part that's a little tricky to remember, just like TryHackMe says, describes here, counterintuitive, which is true. STS tokens vended from a regional endpoint are valid in all AWS regions, whereas tokens vended from the global endpoints are only valid in regions enabled by default. And only some of the regions are enabled by default. Looks like we're going to talk about default regions more, but before we go there, it also says here, a similar case, good to be aware of, the namespace for S3 buckets is global. This is one of the first things people usually learn in AWS is that S3 buckets have to be unique globally. So when you name your S3 buckets, you have to be creative. There can never be two S3 buckets with the same name. And S3 buckets are stored regionally, even though it is a global service. Sometimes this confuses people when you're creating an S3 bucket for the first few times. Even though the name is unique globally, S3 buckets do actually live in a region. The data lives somewhere. So you select a region when you create an S3 bucket. Your bucket itself is associated with a specific region. Then this part, default regions. Until 2017, all AWS customers had a default region of US East 1. I don't even live closest to US East 1, but I do tend to default to US East 1 just because people think of that as like the default AWS region. Another reason I do that is because you always hear when new features, new services, but really new features within existing services are being rolled out, you can pretty much bet on the fact they'll come to US East 1 first, or they will at least be available in US East 1 in the first round of releases. So that's why I kind of tend to be loyal to US East 1. I never want to miss out on the new stuff. But that's not necessarily rooted in fact. That's just my emotional feelings. Anyway, it's talking about the implication being for longstanding AWS customers, AWS assumes customer identities are using US East 1 unless another region has been explicitly declared. And over time, this caused a disproportionate amount of AWS customer resources to be deployed in US East 1. Now, US East 2 and US West 2 are the default regions for new accounts. Beyond having a default region for provisioning resources, certain AWS regions are disabled for customer use by default. And there's a list here of the regions that are disabled by default. This might not be up to date anymore, so I would recommend probably finding the original source. But the regions that are disabled by default are not accessible using STS Global API endpoint credentials. If you wanted to use one of those disabled regions to deploy resources, you would have to manually opt into the region, and then you would have to use one of the regional STS API endpoints to retrieve credentials. Okay, so here are the questions for task 4. What AWS service has both global and regional API endpoints? That's what we were just talking about. So that would be STS, which stands for Security Token Service. And if your AWS account was created prior to 2017, what is your account's default region? So that would be US East 1, the OG region. Okay, so now let's move on to basic concepts, AWS organizations. I'm a proud AWS organization user, so hopefully I'll be able to get some of this, but let's see what's going on. All right, so we're going to get a little bit of an origin story. So this is talking about 2017, the beginnings of AWS organizations. I had never even spun up an EC2 instance in 2017. It's talking about how AWS had been around for a decade with only the concept of an account to centralize management of a company's AWS resources. And for large organizations, managing everything in one account was challenging and inflexible. Furthermore, managing each team or department in separate accounts wasn't scaling well. So in 2017, AWS tries to solve this by introducing the organization service. And remember, we learned above organization service is an example of one of the global services. AWS Organizations allows customers to centralize and standardize key AWS security and operational management capabilities. At its core, I think of AWS Organizations as being a service that helps you manage multiple AWS accounts at scale. Here we see a key value of organizations is the concept of workload segmentation. By collecting accounts under an AWS organization, customers can track various accounts while segmenting individual workloads. So, for example, segmenting applications from networking infrastructure into different accounts, which with separate security boundaries. I'm a huge fan of the multiple AWS account model. I do like separation of concerns. I like to have a different account for different projects. Fortunately for me, I'm not responsible for managing some big organization with a bunch of accounts in it. But if that was in like some enterprise scenario where I was the AWS administrator, I would very much want lots of accounts with each team having their own separate account, separate security boundary, and I would want to get as granular as possible with them. This is what really sums it up right here. Organizations lets you avoid having one account that too many people have access to, that all your stuff is in, and there's no separation. Okay, I had to go get my little cloud-themed drink, and now I'm back, so let's keep reading. Organizational roots, organization units, and accounts. Inside an AWS organization, all AWS accounts are collected in a parent container known as an organization root. The hierarchy in the below image can be summarized as follows. And then we have some nice bullet points that I think are illustrated in this architecture diagram. So let's take a look here. First of all, we have the parent container, which is the organization itself. And from what I can tell, this is like a pretty traditional AWS organization setup. So let's step through these bullets and kind of point out what's what. An organizational unit is a subcontainer under an organization root that may include multiple AWS accounts. So every organization has this root AWS account here at the top of the tree, and then you can divide nested accounts into organizational units. So in this diagram, we have a foundational organizational unit, a prod organizational unit, so production, pre-prod organizational unit, a staging organizational unit, and then a sandbox organizational unit. And organizational units can contain other nested organizational units. See infrastructure organizational unit and security organizational unit as examples. So in the foundational organizational unit, there are functions that I think are thought of here as like foundational functions of the enterprise or whatever. So the infrastructure organizational unit is a nested OU in the foundational OU that contains multiple accounts. And then the security organizational unit is another nested organizational unit that contains multiple accounts as well. That leads us perfectly to the next point. An organizational unit can contain one or more AWS account, and there are several examples of that in this diagram. The infrastructure organizational unit contains two AWS accounts here. So these right here at the bottom level are the different AWS accounts. The security OU has two accounts. The prod OU has two accounts. Pre-prod OU has two accounts. In fact, it seems to me that they all have two accounts. So organizational units can have 1 to n accounts. I'm sure there's a limit, but they can have multiple accounts is the point. And an AWS account can contain one or more user accounts. So we don't see that in this diagram, but for example, the network account might be used by a network infrastructure team. Perhaps there's 4 workers on that team. Those 4 workers might each have their own IAM user account that they use to log into this AWS network account that is part of the enterprise's AWS organization. Overall, a very good diagram gets the main points across. And next is the organizational management account. Organizational management accounts are the primary account associated with any specific AWS organization. Inside each organization management account are a set of rules that can be used to access any account in the organization. By default, this role is named Organization Account Access Role and has full admin privileges against the associated child account. So, this root account has access to a set of IAM roles that allow full administrative privileges in each of these child accounts. Using the management console to switch role or the CLI to assume role, any IAM principal with privileges to assume these roles may be able to perform administrative activities across the whole organization. Then it gets more into single sign on configurations and how to manage different identity providers for access to AWS accounts, which is a topic I really like. I think we're going to get into that in more detail further down in the learning path. And it also makes mention enterprises and other organizations use AWS IAM Identity Center to access child account roles. I actually use IAM Identity Center to access all my own AWS accounts that I use for personal projects or whatever. And I'm a big fan of Identity Center. I think everyone should set it up. I have a video about it if anyone wants to go learn more. Now we move on to organization policies. Organization policies, such as SCPs, which stands for Service Control Policy, allow AWS customers to place restrictions on each child account in an AWS organization. SCPs specifically allow AWS customers to place highly customized security and access restrictions on the organizational root, organizational units, or individual accounts. By default, AWS Organizations attaches an SCP named P Full Access to each account, which allows subscription to all AWS services. And then each root, organizational unit, and child account can have up to 5 SCPs attached. And you can use SCPs to do restrictions such as only allowing approved AWS services, denying root user access, requiring the use of IMDS v2, which is the instance metadata service, and you want to be using v2, you're vulnerable if you're using the first version of it. Deny ability to create IAM access keys would be something you could enforce via service control policy. Regional restrictions, so you could make sure that your account users can only deploy resources in specific AWS regions. You can take away the ability to leave the organization. So this is basically a list of some great service control policy best practices for organizations. Like I said, I think we're going to put this knowledge into practice, hopefully later on in the learning path. Now, one notable thing here, organization policies do not apply to the organization management account. This means that for IAM users and roles in the organization management account, service control policy restrictions are not going to be effective. We move on to a list of other capabilities that the AWS Organization Service has. I'm not going to read through all of them, but hopefully if you're interested in this learning path, you're doing it yourself later on, definitely really take the time to read through this, especially if you're just learning AWS, because these are a lot of great services and features to know about. I see one on here that we talked about earlier, IAM Identity Center, which I use, I really like. Some of the different security services that you can use at the organizational level. So IAM Access Analyzer, which helps you identify when you're giving somebody too much access versus IAM policies. Firewall Manager, Guard Duty, which is an AWS security service. CloudTrail, which is one of my favorite AWS services, which is where you log different control plane activities. So those management events we talked about earlier that happen via control plane. CloudTrail logs all of those API calls for you so you can go back and audit what's been going on. The list goes on and on. So this is really an awesome list. I recommend you read the whole thing. As there are so many capabilities, TryHackMe has the same mindset I do. As there are so many different capabilities, we will not go into detail regarding the specifics of each service. However, it's important to understand as a defender and attacker the native security tools AWS offers and how they impact the attack lifecycle. Okay, here are our questions for task 5. What year was AWS Organizations made GA for AWS customers? So they said that was 2017, which I would not have known. Brilliant. What is the subcontainer for accounts in AWS Organizations? So that will be an organizational unit, if I can spell it correctly. Oh my God. So every time I try and spell anything, it will be very embarrassing for me. So let's hit submit. Okay. And then what AWS Organizations account does service control policies not apply to? So that would be the management account, or you could think about it like the root account. So I got that wrong. What did I do? What's my management accounts, maybe? No. All right, let's do a copy and paste. What AWS Organizations account does service control policies not apply to? Or, okay. Organization management, I bet is what we're looking for here. Okay. Sorry you had to see me struggle. Let's see if that's correct. Excellent. So I'm going to take a break here and then I'm going to come back and tackle task 6. Task 6 is another basic concept, virtual private cloud VPC. So VPC, when you think about networking in the cloud, it's all about VPCs, virtual private clouds. At the core, a virtual private cloud or VPC is a software-defined network topology that represents AWS's traditional network infrastructure offering for customers. VPCs allow AWS users to restrict the connectivity to sensitive resources designed to be isolated or segmented from other workloads and critically from the public internet. So VPC is like your own little software-defined network within the cloud that has logical isolation from the public internet and from other AWS customers' VPCs. That's your little isolated area of the cloud to use. The following networking components are commonly found in an AWS customer VPC: Internet gateway, which allows communication between the VPC and the public internet; egress-only internet gateways, which allow outbound traffic to the internet but restrict incoming traffic from the internet; carrier gateways, which are used to establish direct communication with telecom carrier networks; NAT gateways. So NAT gateways, NAT stands for Network Address Translation, and NAT gateways allow private subnets to connect to services outside the VPC. Now, AWS has a managed NAT gateway service, and then you can also roll your own NAT gateway. DHCP, so if you're not a networking person, DHCP stands for Dynamic Host Configuration Protocol, and DHCP servers typically assign IP addresses to resources instead of having to assign IP addresses manually. So by default, all EC2 instances, VMs in a non-default VPC receive unresolvable host names assigned by AWS, and then you can update those to leverage custom domains. DNS, by default, AWS provides DNS resolution to VPCs via the Route 53 resolver, which is a global AWS DNS service, and then public and elastic IP addressing. AWS maintains over 100 million public IPv4 IP addresses. And I'm sure all this content was written long before this ever happened, but AWS is actually going to start charging money for IPv4 addresses. I think they're kind of trying to push people to use IPv6 IP addresses. But anyway, this is talking about how you can use public IP addresses and elastic IP addresses to associate with your resources so that you can have that IP address and you can allocate it where you want to use it. And then here we have an example of a typical AWS networking architecture. So the outermost box here is the AWS region. Within that region, we have a VPC. So VPCs are within regions. And then within the VPC, we have what I assume are subnets, subnetworks. And this lock here probably indicates that these are private subnetworks and the subnets are in different availability zones, which is a very common architecture. And then within the subnets is where the EC2 instances are running. And then it talks about a virtual private gateway and using a VPN connection. So that's just an example. It doesn't really have a lot of detail, but that's some of the components you're seeing there. Next section is default VPC service capabilities. This is talking about different service capabilities that are configured by default in each AWS VPC using link local addresses. And a link local address just means you can only communicate with that address from within that subnet. So in your VPC, link local addresses that are only usable within your own subnet. These are services available by default in the VPC that you can either configure, work with, use, or you can decide to disable them. So first is DNS resolver. So that's Route 53 resolver that we talked about earlier, and you can disable that if you want, and you could use your own DNS server instead. Amazon time sync service, which I've never really actually used this, but time sync service can be used to do time synchronization for your EC2 instances. Microsoft KMS service, which I believe is something to do with Windows licensing. I'm not very knowledgeable about that, but that's there if you want the KMS service. EC2 instance metadata service. This is a topic you hear about quite a lot in cloud security. The metadata service allows EC2 instances to retrieve information about themselves. So for example, I believe they could get information about what availability zone they're running in. They could get their IP address. The content of the user data script that runs at startup is available via the metadata service. A lot of different things. And you always want to make sure that you are using the metadata service V2 versus V1. So if you're ever using V1, make sure that you fix that. Why do you hear about the metadata service so often in association with cloud security? Well, one of the things that you can retrieve with the instance metadata service is instance metadata credentials. And there was a very famous cloud hack in 2019, a Capital One breach, which is referenced here. And that's part of what happened in that attack path, where instance metadata credentials were accessed and then used for privilege escalation to breach Capital One's AWS environment. Last thing on this list here, ECS task metadata service. So ECS is the Elastic Container Service, which is another compute service in AWS. And if you are using ECS to provision your containers, you can use the ECS metadata service similar to the EC2 metadata service. The last section is VPC endpoints. I'm a fan of VPC endpoints. They can be very useful to solve some problems. They are often kind of expensive, but they are very useful. VPC endpoints allow AWS customers to integrate specific AWS services with their VPC without requiring customers to use an internet gateway, NAT device, VPN connection, or direct connection. VPC endpoints are very useful because what you can use a VPC endpoint for is in your VPC, you can have your resources, so your EC2 instance, for example, your virtual machine running, and you can use a VPC endpoint to talk to AWS services directly without having to navigate the public internet. So your VM in the private subnet, for example, does not have to have access to the public internet to be able to communicate with AWS services. I'm not sure I see this here, but there's interface VPC endpoints and gateway VPC endpoints. And it's a very interesting topic if you're at all interested in AWS networking. Then it says here, this task is only meant to explain the basics of VPCs. Please see the room dedicated to VPCs for an in-depth look. So we're going to learn more about it later. Here are our, looks like 3 questions to answer. What AWS service hosts the AWS DNS resolver? So that would be Route 53. What VPC feature was used for privilege escalation during the 2019 Capital One breach? So what they are looking for here is the instance metadata service. Looks like they're looking for the abbreviation. Lastly, what type of VPC endpoint will allow for network traffic inspection? Okay, so the joke is on me here because I glazed over this part up above, but I think the answer they're looking for is gateway load balancer. So let's scroll back up and see what's going on here. Yeah, so I didn't mention this, but when we were talking about VPC endpoints, one of the things that is mentioned here is that gateway load balancer endpoints can be used for traffic interception and inspection, which is good to know. So let's see if that's the answer. Okay, perfect. Let's move on to task 7, which is the summary task, and then we will be done with this room. All right, so summary task looks like maybe we're going to have something similar to format to the summary in that first 101 room. Says, in this room, you've learned about core AWS services and features. These capabilities are defining features of AWS as a user and as an attacker, right? So you want to know this whichever side you're on, I guess. You should understand the following concepts: how accounts and root users relate to AWS security at a basic level, what AWS IAM is and some of the key features we're going to encounter with IAM, how most services are regional and the difference between regional and global service, the wide variety of AWS services that can be centrally deployed and managed using organizations, how software-defined networking allows AWS accounts to create and interact with network-bound resources in VPCs. This has a little bit to do with when we were talking about control plane and data plane. Then we've got this nice closing line. You may never log in as a root user if you don't have your own AWS account, but you will encounter these concepts when working with AWS. So they're just trying to get us skilled up on the basics. Lastly, to finish the room, it looks like we've got another CTF. Let's have a small test. Click the View Site button at the top of the task to launch the static site in a split view. what is the flag after completing the exercise? So let's see what they've got for us here. I loaded this static site. It looks like it has a few tasks for us. Use your knowledge of basic AWS concepts to click on the correct interface elements to perform 3 tasks. All right, cool. So we were in an AWS console here. Task 1, find the 12-digit AWS account ID. Okay, so we can do that by going up here to the top right corner, and we can copy the account ID right here. Congrats, we found it. Continue, switch regions from North Virginia to Asia Pacific. So we can do that right here using this drop down. I know it's probably a little small, hard to see. Asia Pacific and Sydney. So it looks like that's AP Southeast 2. Awesome. And lastly, create a VPC with a CIDR set as 10.0.0.1/16 and tenancy set as dedicated. All right, cool. Oh, interesting. So it did have our work for it. Was it always like this? It took us right to the VPC console. So we can do create VPC. And nice. A VPC is an isolated portion of the AWS cloud populated by AWS objects such as EC2 instances. We're going to do VPC only. We don't have to name it, so we won't in this situation. We're going to give it a manual CIDR input. So let's see if we can copy this. I think we can. Doesn't say anything about IPv6, so we're not going to worry about that. And then tenancy, we need to change to dedicated. And what dedicated tenancy is about is that with default tenancy, the resources you spin up in this VPC, so EC2 instances is the classic example. EC2 instances that you spin up in this VPC could be sharing physical hardware with EC2 instances for other AWS accounts and AWS customers. Dedicated tenancy means when you spin up an EC2 instance in this VPC, you are going to have dedicated hardware that only your AWS account resources can use. You're not going to share the underlying hardware in the data center. And dedicated tenancy is more expensive for obvious reasons, but that's what that means. Oh, we did our CIDR wrong. What did I do? Okay. I literally can't figure out why I'm getting this wrong. Let me scroll up again and check what's up here. 10.0.0 10.0.0.1/16 10.0.0.1/16. I wonder, I bet that's what I copied an extra space there at the end. Let's see. Let's try now. All right, awesome. And we've got the flag, success. So we'll copy that. What a noob. I could have just used this copy button and then I won't copy accidental spaces. Let's paste the flag. Awesome. So we have officially completed the AWS Basic Concepts room. And next room, I'm going to jump right over to Introduction to AWS IAM. I'm probably going to get a drink and then jump right into it. So feel free to come join me in this next room. And thanks for watching.